graphing a rational function with slant asymptotes, you're going to go through the same set of steps, except for when you find other asymptotes, we're looking at horizontal and slant. So let's do a couple examples for these differences. Okay, simplify if possible. There is no factoring to be done. Y-intercept, so I'm going to have 1 over 0, which is undefined, so I do not cross my y-axis. My x-intercept is my zeros of my numerator. 3x squared plus 1 equals 0. 3x squared equals negative 1. X squared equals negative 1/3. And when I take the square root of a negative, I get an imaginary number, so there is no x-intercepts either. Find the zeros of the denominator. There's just one. X equals 0. So I know that I have a vertical asymptote at x equals 0. Horizontal asymptote, I'm looking at my degree, top and bottom. We would say degree on top is greater than degree on bottom, so we wouldn't have a horizontal. Instead, we're going to have a slant. By long division, if I do my long division, that gives me my slant asymptote, everything but the remainder. So if I take my x, I'm dividing out of 3x squared plus 1, or plus 0x plus 1 to keep my placeholder. On top, I've got to have 3x, so that's 3x squared. Change my sign, subtract, bring down 0x, bring down plus 1, and that's going to be my remainder. I can't multiply to get anything in here. So I don't need to keep going and get the remainder, but I do need to recognize that this is my slant asymptote, y equals 3x. On my graph, what's that mean? It means the line y equals 3x has a y-intercept of 0 and a slope of 3, so I go up 3 over 1. So here's my slant asymptote. Now I need to decide. I still made 4 quadrants. They're just cattywampus now. They're not even. I've got quadrant, the skinny ones, or the big ones. So if I test over here, I'm going to test negative 1. So when I plug in negative 1, I have 3 times 1 plus 1 over negative 1 gives me 4 over negative 1, which is negative 4. Now I know that my diagonal line has to go left 1 and down 3 before I get to my next point. So if I'm going down 4 at this point, I'm definitely going to be below. So here's where this one falls, and this is the left side of my vertical asymptote. Now let's test the right side. If I test positive 1, I'm going to get 3 times 1 plus 1 over 1, which is going to give me 4 over 1, which is 4. And it is symmetric, so that's going to be above this diagonal line. So here's the other part of my graph. Okay, on this problem, start with simplifying. X plus 2, it has to be minus 2. X minus 2, x plus 1 over x minus 1, so nothing falls out, means we have no holes. Y-intercept, if I set x equal to 0, I'm going to get negative 2 over negative 1, which is positive 2. So I'm crossing my y-axis at positive 2. Set my numerator equal to 0 is going to give me x equals 2 and negative 1. So I'm crossing at negative 1, positive 2. Zeros of the denominator, x equals 1. Now that's going to be an asymptote. horizontal asymptote, the top is larger than the bottom. So we have no asymptote, but we do need to do long division, or no horizontal asymptote. So we need to do long division to decide what's the slant asymptote then. So I have to start off with an x, gives me x squared minus x, change, falls out, I have a remainder. So y equals x is an asymptote, a slant asymptote, that has a y-intercept of 0 and a slope of 1. So here's the other asymptote. And my curves, this one's easier, there's no testing. I know I have to be in this part, and I know I have to be in this part.